Number 60. Given specimens uranium-232, which has a half-life of 68.9 years, and uranium-233, which has a half-life of 159,200 years, of equal mass, which one would have a greater activity and why? Okay, so the first thing is that when you're when you are comparing two different isotopes, right? They're both uranium, one's 232, one's 233, and we want to find out which one has the greater activity. We don't really pay attention to stuff that is the same or not changing. So if we're talking about uranium-232 and then uranium-233, they both said that they had equal mass, which means that the masses for both of them are going to stay the same. So if the masses for both are the same, that doesn't really have anything to do with activity. The only thing that's the difference between these two is that the uranium-232 has a half-life of 68.9 years, and the uranium-233 has a half-life of 159,200 years. Which one has the greater activity? Well, when I like to think of greater activity, I like to think of basically which one is breaking down more over a shorter period of time. So we'll say breaking down more over shorter period of time, right? If it's decaying over shorter period of time. If it's decaying more rapidly, right, that means that it has more activity because it's releasing more particles, right? Whether it's alpha emission, beta emission, but you want to find out which one is going to have to break down more over a shorter period of time. And keep in mind that those half-lives, that means that it's the time it takes to get your sample down to 50%. So, for example, if you have a 100% sample of uranium-232, it's going to take 68.9 years to get down to 58%. 68.9 years. Then it will take another 68.9 years to get a half of your half. So 50 divided by 2 is 25%. But now over here, it's going to take 1,059,200 years to just get down to the same amount, which is 50%. Which one is breaking down over a shorter amount of time? It is the uranium-232. So, if that's the case, that's the one that has the greater activity. Uranium-232, and the reasoning because it has a shorter half-life. It has a shorter half-life, which means that it's going to be breaking down more often than the other one. And this is your final answer. So no math is needed here. All we had to do was just compare the half-lives because the masses were the same. And that's it. I hope this helped. Thank you so much for viewing the video. Subscribe to the channel if you haven't already. Hit the subscribe button. Yeah, I think I just said that, but sometimes I'm on autopilot. But honestly, thank you so much for coming here and getting your educational needs. We have physics and math videos on the channel with more subjects coming in the future. So thank you so much for all your support. I hope you have a great day. And I'll talk to you soon, okay? All right, bye-bye.